Alright, this lesson is going to focus on how to calculate the percent composition by mass. The formula is on the back of your reference table. It's simply the mass of the part divided by mass of the whole times 100. This first example, I'm going to just simply use some basic data, and then from this point on we'll be doing GFM calculations to work with different formulas. So here we are analyzing a sample, and we found that it's made of 6.2 grams of carbon, 4.1 grams of hydrogen, and 15.9 grams of oxygen. Our part is going to be whichever element is identified. So carbon in this case will be the part. So we're going to have part divided by whole times 100, which is going to be 6.2 divided by the entire mass. So we have 6.2, 4.1, and 15.9. When I add that together, I get a mass of 26.2 times 100 to complete the numerical setup. And when I plug that in, I get 23.7, and then our unit is going to be percent. So we have out of this compound 23.7% by mass for carbon. All right, here we now are actually going to work with what we're going to be doing in class, more of working with a formula. So you need to be able to write the formula for aluminum oxide. So you should be writing each part, writing down their oxidation numbers, and then considering what I need to do to make this neutral. So you need 2 aluminum and 3 oxygen. So that's going to be kind of the first thing to make sure you remember from our last unit. All right, then we need to go ahead and calculate the GFM. So the GFM for that would be 2 times the mass of aluminum, which is 27.0, plus the mass of 3 oxygens, which is 16.0. So our total mass is 102.0 grams. And then I do want to make sure I also calculate the mass of the part, which is all 3 oxygens, and that has a mass of 48.0 grams. So when we go to do our percent composition, we have part over whole times 100. Our part is, again, the oxygen that was identified, which is our 3 oxygens. So that's why we need to make sure we have 48 in the numerator, and then our whole, which is the 102.0 times 100. And when you plug that in, you should be able to get 47.1%. All right, moving right along. Now we have barium nitrate, which when you balance out the oxidation numbers and charges, you should get this formula. That has a mass in total of 261.3 grams. So now again, I'm going to do part over whole times 100. So I have 2 nitrogen here. So this is where being able to count how many atoms you have is pretty important. So mass of 28 divided by mass of the whole compound, which is the 261.3. Make sure you show that times 100, and when you plug that in, we find that nitrogen is simply 10.7% of the total mass of the compound. And then our last one, now we have ammonium sulfide. So ammonium sulfide is NH4, 2 times, or with sulfur here. So in this case, we need to make sure that we're accounting for the 2 ammoniums. So when we go ahead, we have 2 times the 14 plus the 4 hydrogen times the 2 plus the 32 sulfur. So when you do that, you get 68.0 grams. Now we have to account for the 8 hydrogen, because remember that is our element that's been identified. So I'm just going to simply write this as I have 8 hydrogen times its mass, which is 1.0, over the total mass. Make sure you show that times 100. When you do 8 divided by 68 times 100, you get a percent of 11.8%. And that is it. So as long as you can write chemical formulas from our last unit and be able to calculate the GFM, you should be able to use those to implement the percent composition by mass formula.